Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazif Abdul Latif, and this is a presentation of Group 9, and we will be presenting the structural study of a wall-mounted air conditioning unit. First of all, Chapter 1. I will introduce the structure studies in this project, focusing on its application, materials, safety requirements, and idealized model. The structure studied is a wall-mounted outdoor air conditioning unit. This type of installation is commonly used in residential buildings to save space. The unit is supported by a steel wall bracket fixed to a reinforced concrete wall, which transfers the load of the unit to the building structure. The wall bracket is typically made of mild steel due to its high strength. The wall is reinforced concrete, which acts as the main load-bearing structure. Steel bolts are used to secure the bracket. From a safety perspective, the bracket must be able to support the static weight of the air conditioning unit and resist vibration during operation. Corrosion protection is important because the unit is exposed to the outdoor conditions, and proper bolt installation is required to prevent structural failure. For engineering analysis, the real structure is simplified into an idealized model. The air conditioning unit is represented as a point load acting at its center of gravity. The steel bracket is modeled as a cantilever beam, and the wall is assumed to be a fixed support. This chapter provides the foundation for later analysis by clearly defining the structure, materials, safety considerations, and modeling assumptions. That's all from me. Thank you. And I will pass it to my next teammate.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IZZUDDIN HAMDAN, and I'll be covering for literature review. First of all, the applications. Solid mechanics help us understand forces, stresses, and deformation in structures. Engineers often simplify structures into models to apply equilibrium conditions. According to Hibbeler, static structures must satisfy both force and moment balance to remain stable. Next, stress and force distributions. Wall-mounted units, like air conditioners, mainly carry their own weight. Free body diagrams show load paths and reaction forces. Steel brackets bend at the wall connections, which governs the stress. Mild steel behaves elastically, so elastic analysis works well. After that, load assumptions. For simplicity, loads are often idealized as concentrated force, while wall connections are assumed to be fixed supports. These assumptions allow equilibrium equations to be applied effectively while maintaining safe estimates. On to the next one, factor of safety. This accounts for uncertainties in loading, material properties, and environmental conditions. Safety margins keep stresses within the elastic limits. Overall, the literature supports the use of static equilibrium, stress analysis, and factor of safety to assess the performance of the wall-mounted air conditioning unit. That's all from me. Now I'll be handing it to my next teammate.
Assalamualaikum, my name is FAHREEN bin HAMDAN, and today I will present about the methodology for our assignment. So first of all, we need to draw the free body diagram. So this is all the dimensions that has been measured, and this is the force on y-axis, force on the x-axis, which is and also the weight, and the length and all the other dimensions. There's bolt here too, two bolts by the way. So the equation of equilibrium, the mass for the compressor is 35 kilograms. So we divide it by 2 to get 17.5, which is each bracket support, since there is two brackets, the left and the right one. And we can find the force by using this formula, the mass and gravitational acceleration for the weight. So we can get 171.68 Newton, which is the one that reacts to the SI unit. Then we can find force on X, which is the only force reacted is here that mounted to the wall, which is the Rx. Since it's equilibrium and it's static, we equal it to 0, so Rx is equal to 0. And next one is the y-axis force, which is which is the RY and the weight. So assuming going up is positive, we can get the RY as also as 171.68 Newton. Next here is the moment. So we have the moment for the wall, which is the moment reaction plus weight times with the length. So length from the wall here is 33 centimeters. Converted to meter is 0.33 meter. So time it with the weight, and we can get the moment reaction is 56.65 Newton meter. And here is maximum shear force, which is V max equal to W because it's static, it's equilibrium, and the only force we add to it is Ry and W. So we only use W here, which is 171.68 Newton, and the maximum bending moment, which is on the wall. So here, the bending moment here is weight times with the length of the wall to the AC unit where the weight react, and we can get the maximum bending moment as 56.65 Newton meter. That is all from me. I will pass it to my other teammates. Thank you.
Assalamualaikum, my name is Muhammad Akmal. For part discussion, I will explain the structure behavior of the wall-mounted air conditioning outdoor unit based on load analysis, internal and external force, safety consideration. Firstly, the main external load acting the structure is the weight, safe weight of the air conditioning outdoor unit. This load acting vertically downward at the center of gravity of unit and is considered as a static concentric load. The load is transferred from the unit steel bracket and finally to the reinforced concrete wall through the anchor bolt. Based on free body diagram and equilibrium equation, free friction force and moment generated are the wall support. The steel wall bracket behaves to similarly to the cantilever beam fixed to the wall. As a result, internal shear force and bending moment are induced to the bracket. This internal force produces the mechanical response. In the form bending shear stress, bending stress, dominant stress due to the cantilever action, while shear stress is relatively smaller. Since the bracket material is mild steel, which behave to elastic within yield limit. Next, the allowable force the structure determined based on the properties of maturity and the applied factor of safety. This ensures the working stress remain well below yield strength of the material, prevent permanent deformation under normal operating condition. Finally, structure safety is evaluated using the factor safety, which account for its loading, material property, insulation quality, and environment exposed.
And greeting, my name is MOHAMAD ZOLKARNAIN. Today I'm presenting a chapter 5 conclusion for our structure. Summary of finding. Our goal was to determine if the mild steel bracket currently in use are safe and reliable under real world conditions. We idealized the structure into a mechanical model and used a FBD to calculate the specific internal and external loads. For this study, we analyzed a unit mass of 35 kg, meaning each bracket supports a load of 17.5 kg. Using equilibrium equation, we derived three critical values. First, a vertical reaction at the wall. Second, a maximum shear force. And most importantly, a maximum bending moment at the wall connection. Structural performance. Our analysis confirmed that the structural performance is stable and adequate. Because the brackets are made of mild steel, they as hybrid linear elastic behavior. This means the moment remain well within the material yield limit. We have also calculated a conservation factor of safety, which ensures that the structure can handle unexpected vibration from the compressor without any permanent deformation. Suggestion for improvement. For correction, we recommend hot dip galvanizing to combat Malaysia high humidity and prevent material thinning. Second, vibration. Integrate rubber multipad to prevent anchor bolt from losing due to dynamic loads. And lastly, maintenance. Every 2 years, check the bolt and the wall. This ensures the bracket stays safe and does not fall as it gets older. Final summary. Status: the current structure is robust and performant within safe limit. For conclusion, by adding vibration, isolation, and superior coating, the maintenance and reliability are significantly extended. And lastly, goal, permanent safety through regular maintenance and material upgrade. I think that's all for us. Thank you.